Hello everyone, so let's continue with some buffer solutions and calculating their pH. And we have another example here where it says a buffer solution consists of 0.3 molar formic acid and 0.52 molar potassium formate. Determine the pH of this buffer solution given that the Ka of formic acid is 1.7 times 10 to the negative 4. Alright, so we're told that this is a buffer solution, but of course you could also determine that through the fact that you're given formic acid and the formate anion, which is, or the formate anion, which is, of course, its conjugate base. So the conjugate base of formic acid, so you can see it's just the deprotonated form. They differ by 1 proton. And hence, if you mix those two species in relative or some significant quantities, you'll form a buffer solution. So to determine the pH of a buffer solution, we always use the Henderson-Hasselbalch equation. And so this is a straightforward, we need to calculate the pH just using the Henderson-Hasselbalch equation. There's nothing really to this question, it's just a reminder of the basic facts. How to calculate pKa? We need to use the negative of the log of the Ka. What is the base? The base in this case is, of course, potassium formate, so it's HCOOK. You can also say COO minus, or it will be the same as the entire salt, and the acid is the formic acid. So this is negative log 1.7 times 10 to the negative 4 plus log so now we just put the right things at the right place, 0.52, that is the potassium formate, and 0.30 for the formic acid. Then two significant figures for the Ka of formic acid, and so we round to 4.01. Right, as always important, the Ka is for the acids. If you use the acidic form of the Henderson-Hasselbalch equation, then the Ka corresponds to the acids. I mean, it makes sense, it's Ka, so it should be of the acid. And you just ensure that everything is in the correct places. This also makes sense. I mean, it's an acidic buffer, so the equilibrium that you are looking at is that of formic acid. So formic acid with water will form HCOO minus plus H3O plus. Alright, and we have significant quantities of the acid and its conjugate base, and so hence why we have a buffer solution and why we use the Henderson-Hasselbalch equation to calculate the pH. Okay, relatively straightforward question, straightforward application of the Henderson-Hasselbalch equation. If we really wanted to be excessive, we could have used an ice table. It's perhaps a good test of how you could use an ice table to see if you get to the same pH, just to test your ice table calculation skills. But anyway, right, so I'll see you in the next video.